Good lighting is often a matter of reflection, and that's why early on lamps often came with reflectors. But in 1935, a company figured out how to make light bulbs with built-in reflectors. Sealing the reflectors inside the bulb kept them clean and maintenance-free. As track lights or in recessed fixtures, reflector bulbs can light up a room at the flick of a switch. The creation of these bulbs begins with the bulb shell, known as the glass envelope. It's comprised of numerous raw ingredients and recycled glass. Production is almost entirely automated. An operator activates equipment that weighs the ingredients and releases them into a huge hopper where they're mixed thoroughly. This concoction then flows into a furnace, heated to 1500 degrees Celsius. It takes up to 24 hours for the mix to melt into a taffy-like glass. It flows between rollers that shape it into a ribbon. One roller has little pockets on the surface, which form the ribbon into segments. These devices, called blowheads, inflate the glass segments through holes in the conveyor chain. This stretches the glass into oblong bubbles called blanks. Iron molds encase the warm and pliable glass blanks. The molds spin as the glass hardens into the desired shape. The glass blanks now look like upside-down martini glasses. This is the reflector bulb's glass envelope. It takes just seconds for a glass blank to be transformed inside one of these molds. The envelopes are still linked by a ribbon of glass at the top, so an automated hammer now gently knocks them free. The glass envelopes cool down slowly. This stage, called annealing, toughens the glass to reduce brittleness. They measure the thickness and diameter of one of the envelopes. If it's not up to standards, the entire production run will be crushed and the glass recycled into new ones. But the envelope is good, and so production continues. They lower the envelopes over nozzles that inject hydrofluoric acid. It coats the inner surface of the glass with a frosty finish that will smooth the light emitted by the bulb and widen the beam. The envelopes now head down a chute into a padded channel that cushions their fall. Guides gently position them. Then other devices thrust them into holders which move them down the line. Next, a robot inserts aluminum wire in a heating coil and places a protective metal dome over top. Suction cups pick up the glass envelopes and slide them onto the wire and dome assemblies. A pump pulls air out of the bulb as an electrical current energizes the heating coil to melt the aluminum wire. The aluminum adheres to the walls of the light bulb shell, giving it a reflective finish. The glass envelopes then move on to be stamped with the company trademark and other information. Meanwhile, on another production line, they're preparing the glass mounts for the filament and wire contacts. A cutting wheel slices them to size. The tubes then travel past a flame, which melts the ends just a bit to make the edges smooth. Once they've cooled, grippers deliver the tubes to a more intense flame, which flares them at one end. Coming up next, we'll show you the inner workings of the reflector light bulb. A reflector light bulb can cast one's surroundings in a whole new light, one that's more intense and focused. The source of this light is an electrified filament of wire, and assembling that filament in the bulb is a very delicate task that's performed entirely by machines. Production now focuses on the glass tube that will serve as the mount for the filament and its electrical contacts. Machinery inserts 2 copper wires into each tube. These are the lead wires that will eventually connect the base of the bulb to the filament and deliver the electric current. These long glass tubes will be used to suck air out of the light bulb, preventing oxygen from reaching the filament and destroying it. They protrude from the glass mount, but that's just temporary. They will later be cut shorter. Torches now melt the glass mount, lead wires, and exhaust tube together. Mechanized fingers then pinch the layers together, and the wires are now encased in glass, but protrude from the glass base. Grippers transfer the closed mounts to a carousel. It revolves to allow the mounts to receive a coil made of tungsten metal. This coil is the filament of the reflector light bulb. Mechanized fingers attach the small coil to hooks on the 2 lead wires. The coiled filament is wobbly, so next it gets some support. First, machinery bends the lead wires to move them and the filament out of the way. Then, a robot presses the tip of the glass exhaust tube onto a burner. The tip melts, allowing a metal support wire to be embedded into it. Another robot bends the lead wires to position the filament adjacent to the support wire. The next station loops the wire around the filament. This gives the filament the necessary support, and it stops wobbling. This 2-pronged device then straightens out the lead wires. The mount is now upright and riding another carousel. Flippers set it straight, so a metal disc can be installed on the pinched section of the mount. This disc is reflective. It will bounce light downward to the shiny coating inside the light bulb to create just the right effect. With the disc wrapped around it, the assembly is now positioned on the next turntable. Suction cups deposit the glass envelope on the assembly to encase the filament and reflective disc inside. The holder twirls the bulb as it travels past a row of torches. The flames melt the neck of the glass envelope, and it closes around the glass mount. This secures the filament, contacts, and reflective disc inside the bulb. Another set of torches, heated to a much higher temperature, trim the base of the bulb. Molding devices now move in to shape the bottom of the bulb so a metal base can be fitted to it. A gripper then puts that metal base on a track to meet up with the reflector light bulb. By now, the bulb has been flushed of oxygen and filled with argon gas so it will last longer. The metal base finishes it off and will allow the bulb to be screwed into a light fixture. Another flame heats the metal base to cure adhesive that was pre-applied for a strong bond to the bulb. Then, robots cut off protruding wire and form a contact on the base. It has taken just 12 minutes to assemble this reflector light bulb, but it will provide about 2,000 hours of light.